So what we're starting with for operations of polynomials are basic exponential rules just to practice them so you get used to them again because I don't know how long it's been since you've used them. So for example, if I have a to the 5th times a to the 2nd, what does that equal? Okay, so let's expand it to explore. So this is 5a's times 2a's. How many a's do I have in total? 7. So this is the same as a to the 7th. So when I'm multiplying two terms together with an exponent with the same base, so they both have to have an a here or an x or whatever it is, I add their exponents. I know, magical. What if I have a to the 5th raised to the 2nd power? Which is the same as a to the 5th times a to the 5th, which means I have two groups of 5a's.
That would have been nice to know.
How many a's do I have in total? 10. So that is the same as a to the 10th. So logically, if I'm raising a power to a power, I multiply the exponents together.
I wouldn't say that because I'm already tired.
So then what if I have 4a squared cubed?
Now I'm tired. I would not tell you.
That means I'm taking 4a squared and I'm multiplying it by itself 3 times. So that's the same as 4a squared times 4a squared times 4a squared. I can multiply the individual pieces. So what's 4 times 4 times 4? 64. What's a squared times a squared times a squared? 6. I have 3 groups of 2. 3 and 2 make 6. So this is 64 a to the 6th.
Oh,
Magical. Magical.
Wait. Oh, that's still.
This is too easy. This can't be the one. This can't be what we're doing.
Okay. So now I have the quantity 3a squared b cubed all to the 4th power.
Let me guess. They multiply by themselves.
Right, but there's another way I could write that because I don't really want to write that 4 times. So this is the same as 3 to the 4th times a squared to the 4th times b cubed to the 4th. I can solve those individually. So what's 3 to the 4th power?
12.
Not 12.
Okay. It makes sense.
81. What's a squared to the 4th power? A to the what? 8. Remember when we're raising a power to a power, we multiply. So now I have 81 a to the 8th. And then b cubed to the 4th power becomes b12. So these are applications of exponential properties. These are just the multiplication ones. We'll do the division ones in a little bit. Are these somewhere in your brain ringing a bell?
No.
That makes me very concerned because this is an Algebra 1 standard.
The top one. This is still a good teacher.
I didn't learn it.
Our team did.
That makes me so sad. Okay.
Just with 5. I didn't do
Okie dokie. So let's do a couple more examples just so we really get it down. If I have 3 times 4 squared, which one of these do I do first? Do I do the 3 times the 4 or do I do the 4 squared? The 4 squared first. Please remember your order of operations. Please. So then I get 4 squared is 16. 3 times 16 is 48, and I get my final answer. It would not have been the same if we did the 3 times 4 first, because 12 squared is not 48. Okay, it would not have worked. Then what if I have this? So what if I have the quantity 3 times 4 squared? Correct. We would do the parentheses first and then multiply or then square that answer. Or you could always split it up using exponential properties, which is, I could also do 3 squared times 4 squared. Either way, it's going to work out the same as if I did 12 squared, which is 3 times 4. 144 either way. However, following order of operations, it is most logical to do the 3 times 4 to get 12 and then square the 12.
I can't square.
What if I have negative 3 times 4 squared?
Well, then it's negative.
Still 144. Negative 3 times 4 is negative 12. Negative 12 squared is 144. What if I did the negative of 3 times 4 squared? Positive or negative?
Positive.
Negative. We have to do what's inside the parentheses and then the exponent, and then we multiply the negative 1 in. So 3 times 4 is 12. 12 squared is 144 times negative 1 is negative 144. This is the most common mistake I see on any math test.
I mean,
Okay.
at least that's like a simple mistake. And
But it has very dire consequences depending on how early you make that mistake.
Okay, I literally felt that.
Okay. Any questions on any of the examples we've done? I know they seem really silly or really easy, but they are fundamentals.
Okay,
Any issues so far?
Yes.
is this all we're doing on homework?
No.
Okay, so we do what's inside the parentheses first. PEMDAS starts with parentheses.
Why would you say that?
And then E is exponent. So 3 times 4 is 12, 12 squared, and then multiply the negative 1 in. Okay, so
Is there word problem?
there are always word problems. Not today, but there are always word problems. Don't
I don't like those
that.
words.
Okay.
It's like real world problems, but it's about a plane and someone figuring out how far the plane is. There's nothing even about that.
Okay, so we're going to explicitly write out these rules just so you guys have them somewhere to refer back to. So if I have, these are called monomials, by the way. So a monomial is a polynomial that's all one term, which means every part of that term is connected by multiplication or division. There is no addition or subtraction happening in here. Okay? So if I'm multiplying 2 values with the same base together, what do we do with the exponents? We did it already. We add them. So this is the same as a to the m plus n power. Similarly, if I have a to the m and I'm taking it to the nth power, what am I doing with the exponents there? Multiplying them. So this becomes a to the m times n power. So what if I have 2 numbers or 2 different variables all being taken to the m power? We apply the exponent to both of these terms and multiply their answers. So this becomes a to the m times b to the m. And then one last one. What if I have a to the m times b to the n, and I want to take it all to the p power? That p is going to multiply to into each of the exponents that exist inside that parentheses. So this becomes a to the m times p times b to the n times p. So as always, we're going to do some lovely examples of that. Lovely. Huh? Well, those were practice. These are actually applying these rules. We won't do all of them because we don't need all of them, but it's still helpful. Okay, so the first one I would like to do. 1/2 a squared b all to the 3rd power.
Oh, there's fractions. I'm just gonna
Okay, so one of my rules says if I have terms multiplied together inside of my parentheses, all raised to an exponent, I can take each of those terms individually raised to that exponent and multiply their answers together. So this is the same as 1/2 cubed times a squared cubed times b cubed. 1/2 cubed is the same as 1 cubed over 2 cubed. So what's 2 cubed? 2 times 2 times 2. 8. And 1 cubed is just 1. So this is the same as 1 over 8 times, what's a squared cubed? A to the 6. And what is b cubed? B cubed. There you go. What we did, but 1 cubed is just 1. So it didn't change anything. We always make this into real numbers. But this is where we will stop here. So I have 1/8 A6 B3. Any issues with that? How many of you kind of like this?
No.
I liked it.
I love it.
Fractions.
This is my favorite thing we've done all year.
It's not overly difficult. Sometimes it's just a little.
It just hurts your brain.
7th grade.
I like all the tests though. Test date's my favorite thing. You're really gonna do it long term?
Okay, next one. The quantity 2a to the 4th times the quantity 3a cubed b times the quantity negative 4a squared b cubed squared.
I did the
Well,
Why?
Can I get those?
No, not an option.
Is that division sign or?
That's a negative.
You have to distribute.
I can't remember what it is.
You have to factor.
Yes. Wait, I can do that. We're good. No way.
You have to factor it.
We will not be factoring it. We will be foiling it.
Oh, we're foiling.
I meant to say that.
What does that mean?
Can you please show
Show
us?
how to foil it?
I will.
It's a sign we're
Oh, that's a multiple.
I'm about to shut my board off and turn it back on again. That's what's going to happen.
What is that dot supposed to be?
That's supposed to be a minus. That's a negative. I just couldn't erase.
I thought it was negative before.
It was, but then Shane had me convinced it looked like a division sign, so I tried to fix it and it didn't work. So, okay. Okay. So, as I'm looking at this, that third term just looks terrible, so I'm not going to touch it. I'm instead going to look at these first 2 terms.
They still look terrifying.
But I can go ahead and multiply those together, and it's a much more manageable multiplication than trying to do all 3 at one time, right?
Yeah.
So when I multiply, I'm really just putting like terms together, and then I'll be adding the exponents on those like terms. Except for the whole numbers, those actually get multiplied. So 2 times 3 becomes 6. I have an A4 and an A3, which means that that's going to become
7.
A7. And then I only have one B present, so it has to just drop back down. So that multiplied becomes 6A7B.
This is where there is the other one. Okay.
Are we okay with that?
Wait,
What?
why is B by itself? Why didn't
Because I didn't have any other B's to multiply it with.
You might like.
Why can't you just do 2AB?
No, because I have an A4 and an A3, and they have to add their
I'm not
exponents.
gonna question it. I'll just
Okay.
let it go.
Okay. So now what I want to do is I want to make this a little bit more manageable, so I can multiply it with the 6A7B that I already found.
It's perfect.
So to make it more manageable, I'm going to take that square, and I'm going to square everything that's inside that parentheses. So what is negative 4 squared? 16. What is A squared squared? A to the 4th. And then what is B cubed squared? 6, because we're multiplying an exponent to an exponent. So that becomes B6. So now I have 6A7B times 16A4B6. And I can go ahead and multiply this together. What is 6 and 16?
Multiplied by what?
12.
96. A7, A4 becomes what?
11.
A11. And B and B6 become
7.
B7. and then we are done.
There's no X. Yeah, but it equals 1, buddy.
We assume if there is no exponent present, that it's a 1 at all times.
So that's it.
That's our answer for that one. Was that a little easier than we thought?
Yes, it actually.
Maybe.
No, it's not easier than I thought. It's just there.
It's just there.
It actually makes sense.
I'm glad it actually makes sense. Okay, so let's go ahead and do one more.
We don't need to. Wait.
What's wrong? Because I have a B1 and I have a B6. This is not all we're doing today.
Try to graph A11, B7. And then the 96 is the maximum.
Is it?
Change after call.
I haven't played that. I've tried the
Okay, so I have 5a cubed all squared plus 2a squared all cubed.
Never said.
They said we're doing one.
I didn't actually never said we weren't doing pluses. I said monomials don't have addition or subtraction, and that doesn't mean we can't put them together.
Oh, we're
We're
doing
doing all of them.
Okie dokie. How would I solve the 5a cubed squared? What thing?
You multiplication.
3 times 2 is 6.
Same. So we do the 5 squared and we do the a cubed squared. I heard it over here. So a cubed squared becomes a6. 5 squared becomes 25.
Oh, I forgot to do
Correct? I kind of do the same thing over there. What's 2 cubed?
that.
Wait, no.
2 cubed is not the same as 2 times 3. Please don't ever do that. Please. That is the same as 2 times 2 times 2,
It's 8.
which is 8. And then what's a squared cubed?
6. Let's go.
I can put these two terms together because they contain the same base with the same exponent. So because they're both a6s, I can put them together and just add their coefficients. Yes.
What happens if they're not?
Then you cannot put them together and it would stay exactly like this. We can only put them together if they're the same base with the same exponent.
Oh my.
So that becomes 33a6.
Wow.
Questions, concerns, or issues there?
No.
Why is it only
Yeah.
A6?
Why is there? Because that's just how it came out.
Wait, what?
What?
I only had one variable here that multiplied and it became a 6, and I only had one there that multiplies it became a 6.
So it says 6.
So it stays 6 because I'm just putting these parts together. Just like if I had 3x and I had 2x, I'd put it together into 5x.
Why did we add them together?
Just like 7.
To simplify it. Because we were multiplying here. Here I'm just adding.
Oh.
What? No, when you multiply.
Wait, so what if they're not the same?
When we multiply the terms together, we add the exponents. To add the terms together, the exponent doesn't change.
Okay.
If they're not the same base with the same exponent, we cannot put them together. They would stay separate.
Okay, so they have to have the same.
They have to have the same base and the same exponent.
But what if it's A2 and A3?
Cannot put them together.
So it just stays A2 and A3 because you can't add that? No, you multiply that.
If we were multiplying A2 and A3, then I could make it A5. But if I was doing A2 plus A3, I could not do that. Okay, so let's look at some division properties. For instance, if I have A to the 5th over A cubed, let's go ahead and look at what this looks like expanded, and then we'll come up with a rule from there. So this is the same as having 5 A's in my numerator and having 3 A's in my denominator.
Oh, I remember doing this, and then you like cross them out.
What do we notice?
There's a bunch of.
They're not the same, but that doesn't mean they don't share some number of A's, right?
What the answer is like 1 A.
Hold on. Shh. I noticed that there are 3 A's in my denominator, but there are also 3 A's in my numerator that can cancel them out,
Just subtract.
which means I'm just left with an A squared left.
So easy. This might actually be my favorite.
I'm glad.
Must be nice.
I still don't like it.
So then what happens if I have
important when they smaller, so I did it again for math, but we still didn't know how to do it.
Yeah, I
Your
know.
point.
What happens when you give to people?
What if I have 4a squared b cubed in my numerator and 8a b5 in my denominator? We're gonna go ahead and do the expanded form just so we can see what's happening here.
So we can, like our.
Yes, this will be on your homework. Okay, so I expanded. I have 4, and then I have 2 A's, and I have 3 B's. No, there are 3 in the numerator. I haven't got to the bottom one yet.
She's not talking about this.
In my denominator, I have an 8, I have 1 A, and I have 5 B's.
Does that get rid of one?
Oh,
Yeah, we'll see. We can only cancel out if I have something in the numerator that cancels out something from the denominator and vice versa. So clearly, I'm not gonna be able to cancel everything out, but that doesn't mean I can't simplify it a little. I have 1A present in my denominator. Do I have an A in the numerator that can cancel that out?
Yeah.
Yes, I do. So this A and this A cancel. I have 3 B's in my numerator. Do I have at least 3 B's in my denominator?
Yes.
Yes, so those cancel. I can also look at my whole numbers. What can I take out of a 4 and an 8? 4, which leaves me with a 1 in the numerator and a 2 in the denominator. So this simplified is AB squared in my numerator over 2. I did not mean that. That's just an,
Hey, a B squared is on the bottom.
yeah, I know. It's just an A in the numerator and then a 2B squared in my denominator.
So we get rid of the 1 altogether.
Well, 1A is the same as A, so I don't feel the need to write it. If you do, that's fine. It's not wrong.
So it's A over 2B squared.
A over 2B squared, yes. So this, of course, leads into some rules that we have for division of exponential terms. If I have A to the M over A to the N, this is the same as A to the M minus N. So I subtract the exponent from the opposite side of the fraction from the exponent present in the side I'm working on. So when it crosses the fraction bar, it becomes the opposite sign or the opposite operation. Another rule I have is if I get something to go to 0 as an exponent, that's always equal to 1 no matter what my A is. So it could be 100 to the 0 power. Guess what? That's still 1.
whoa.
Wait,
So it'd still be 100 times 100.
No, it'd just be 1. That's it. If it's anything to the 0 power equals 1.
That's
Oh, okay.
Anything to the 0 power. Yes, Sam.
What if when you like subtract them, what if the number on top is like
Smaller,
and, like,
then you
it's
would
negative?
subtract this one. So I always say the bigger one stays and we subtract the smaller one. So this is just a general rule. It also could have been I have 1 over A to the N minus M. Like it works the same way. I'm just saying that when we have division, we subtract, no matter which direction we're going. Yes?
Is it possible to have a number outside of the fraction? Like outside of the
Like a 3 sitting out front?
Yeah.
Yeah, absolutely. And you just multiply it in at the end.
What is this used to solve?
Yes.
What if the exponents are the same?
No, I mean, no, I'm not talking.
That is a wonderful question. What if I have A to the 4 over A to the 4, for example?
0.
I'm going to have 4 A's in my numerator, and I'm going to have 4 A's in my denominator. How many A's are going to be left?
0.
0, which means my answer is 1.
What? 0?
Anything to the 0 power is 1. It's no different than having 4 over 4 or 5 over 5. They cancel each other out and become a whole number 1. Same concept. Okay, there's one more thing. Well, no. If I have something to a negative power, it moves to the opposite side of the fraction. So if I have an A negative 1 in my numerator, that becomes 1 over A to the 1, or just A. Anytime it's a negative, it moves to the opposite side of the fraction and becomes positive.
add it to the
Just add it, yeah. Same thing if it started in my denominator, it would have moved up to my numerator and become positive. So it doesn't matter what fraction, what side of the fraction it's starting on. Once it crosses that fraction bar, it becomes the opposite sign. So what we're gonna do is some examples, because I know how much you guys are super loving this.
Yeah.
Is this the rest of the concept?
Yes,
Okay, that's what I meant with is this it?
for the most part, yes.
Oh, for the rest of the part.
Three times my day.
Okay, so a couple examples. I would like to start with 144, x to the 5th, y to the negative 3, z to the 4, all over 12, x to the 6th, y squared, z to the 4th.
We sure switched gears real fast there.
Time.
Now I give me nap time.
Okay, I'm just gonna take an hour to write
I almost put that line.
this.
Oh my god. Paige, how do you rest your head with glasses? I can't
Relearn.
You adapt, right?
Go you. I say I always took them off, but I laid down for Thompson's class.
My mom's trying to make me do a handwriting. She says okay, so I can.
I didn't know they offered handwriting.
I'm doing my
No, she was going to give me one.
Oh, got it. Some people I think could benefit from
I
that.
can't see crispy. I see a little blurry lines.
I used to do shit for 90 credits, so like.
I'm still readable.
I
They give me a pen, but
I got blankets if you want to get real comfy.
No, I said I need to get up, otherwise I'm gonna fall asleep down here.
Okay, so let's start simplifying.
I'm like, no.
The first thing I like to do is to reduce my whole numbers. So as I'm looking at the 144 in the numerator and the 12 in the denominator, is there anything I can take out of both of those?
12.
I can clearly take a 12 out, which means I'm left with a 1 in my denominator and a 12 in my numerator,
Oh.
correct? Okay, once I have simplified my whole numbers, I like to simplify in the top first and then in the bottom. So I ask myself, is there anything I can put together in that numerator?
Yeah.
No, because there's nothing that has the same base as another term, right? This one has an x, that has a y, that has a z. There's no repetition. Is there anything I can combine in my denominator? No. So I can skip that step, which means now I'm going to simplify across the fraction bar. I always ask myself, is there anything negative that I can move down? Yes or no?
Yeah.
Yes, what is it? The y negative 3 is going to move to my denominator and become y positive 3. Once it crosses the fraction bar, it becomes the opposite sign. Is there anything from my denominator I can move up to my numerator? No, because there's no negative exponents. Once I've done the moving, I re-simplify. So is there anything in my numerator I can put together right now?
Yes.
No, there's no repetition of bases. So I just rewrite it the way it is. I have 12x5, z4 over. Is there anything in my denominator I can put together? I have a y squared and a y cubed, which means I'm multiplying y squared times y cubed, which means what for my exponent? y5. When we multiply, we add exponents. So now this becomes x6, y5, z4. No, we're not done.
Can you cancel off the beats?
Hold on, we're getting there.
You still have to cancel it.
We still have to get it, so there is no repetition of base anywhere in here. So it means there can only be one x, there can only be one y, there can only be one z term. So now what I like to do is I like to figure out what I'm subtracting. So looking at my x's, which one's bigger? The numerator x or the denominator x? The denominator, because this is a 6 and that's a 5, which means I'm going to be subtracting this 5 from this 6. So when I write that, this becomes 6 minus 5, and this one goes away.
Oh.
So it's going to become x, right? I do the same thing with my y's. Is there a y in my numerator to compare with the y in my denominator? No, so the y in my denominator is staying. What about my z's? Which one's bigger?
They're both the same.
Neither. Because they're the same, they're going to eliminate themselves altogether. So Z is gone, which means my final answer is 12 over x times y to the 5th.
Oh, that's not different.
Questions? How much do we hate that?
I thought that was the best
Very
part.
much so.
Could be worse.
Could be worse. Okay, I like that.
This part is
Optimistic.
easy.
As
Because
long
you're
as I
just
haven't liked
putting
the math
X's on the
class,
screen until
well,
you get to
basic
the smallest
multiplication.
number.
You can. It's just really going to be terrible when I give you x to the 16th or y to the 24th.
Well, no, because you just like do the math. Okay.
Okay, next one.
Next one.
Yeah, we're not done.
This is like one of the easiest lessons she's finally given us.
I think you should like stop.
One
You see, these are private homes that I always skip when Mrs. Ring will post them on her Facebook for like Math Monday or something.
Yeah, it's literally addition.
I never answer them.
I will stop after this example and give you guys some time to look at your homework. I will make this a 2-day lesson.
Okay, that's better than I thought.
So wait,
so
so
the
the homework's due in 2 days?
The homework is due at the end of day tomorrow
You
still,
want another
because you're gonna have class time to finish this out.
Oh,
I might make it due Thursday, I'll think.
You should have like started it. Like then maybe would have been more like about.
More open-minded. Okay,
So we have more time to think.
so as I'm looking at this, I like to simplify individually in the numerator and denominator first. Since I have parentheses with an exponent, I clearly have to do that part first. So in my numerator, I'm gonna distribute that 2, right? So it's gonna become 3 squared times x to the 5th squared, correct? What's 3 squared? What's x to the 5th squared? Hold on. Okay, so that becomes 9x to the 10th. What about in my denominator?
Oh crap.
Do you really want to distribute a -3?
Oh, when you bring it up, right?
No,
Bring it on.
because that is a negative exponent, it cannot exist on the current side of the fraction it's on, which means I need to move that entire thing to the other side of the fraction. When it crosses that fraction bar, the negative part will come off, and it's just going to be a +3. So then this becomes, the numerator I already had times -2x cubed to the +3 power. And I have no more denominator right now.
Why didn't that? Why didn't that?
The whole thing.
Yeah, why did the -2 turn into a +2?
Because it's not in the exponent. It only applies when I have a negative in the exponent.
Oh, so only exponents?
Only negative exponents does this apply. So then from here, all I need to do now is cube everything in that second parentheses and then combine with my first parentheses. What's -2 cubed?
8. -8.
-8, good. What is x cubed cubed?
Or
What's 3 times 3?
Oh my
27.
god.
9.
27.
Not 3 cubed, it's 3 times 3.
Oh, you just do 3 times 3.
Yeah, when we're doing a power to a power, we just multiply them together. Okay, so now I have 9x to the 10th times -8x to the 9th. I'm multiplying these together, so I have 9 times -8 is, and then I have x to the 10th times x to the 9th. They are the same base, because their base is x. So I'm going to add the exponents. Becomes x19. So -72 x to the 19th power. How do we feel about this? I do need to point something out to you before I let you start working on your homework because it's a very common error, just so you guys don't make it too. So if I have, I'm just gonna make this up, so say I have this. What is the first thing I really need to do?
You can bring down the x.
Move that x. The -2 does not come with it.
Just
They are not the same term. Just because they're connected by multiplication doesn't mean they travel together. Okay, just the x would move, the -2 would stay in the numerator. The same thing applies. If I have a number down here next to something that's like y -4, it's gonna stay where it was originally. Only the variables move. Okay, I cannot enunciate that enough. Only the variables move. Are we good with that?
Yeah.
Everybody say it with me. Only the variables move.
So if you were to like move it, would it just be like t to the 4?
Yeah, so this would be negative 2y squared over x4z. Because I literally just moved this down.
Oh.
I didn't multiply anything in. And then I couldn't do anything else with that, so I'd leave it.
So
Go ahead.
we're doing the homework in class tomorrow, so
We are going to have some time to do it in class tomorrow, yes.
like.
So you should definitely look at it right now and try some problems.
And then I don't have to do it after school.
Correct. Because you'll have time tomorrow, yeah. Another thing, it is not simplified if we have repeating bases. So if I have more than one x or more than one y or more than one z term, and if there's still a negative exponent, you're not done. Okay, simplified means as far as we can go. This would be as far as we can go on this problem. Okay, make sure you're keeping that in mind. We will finish this lesson tomorrow.
Is this our grade or no?
That's freshman.
Oh, ours, I think ours is 10.
Ours grade is